The neuromuscular electrical stimulation. So in 18th century, modern neuromuscular electrical stimulation was developed by the Greeks and Egyptians. There was Franklism, Faradism, Galvanism. In 20th century, we got TENS, especially the high TENS. Neuromuscular electrical stimulation is seen to produce burst modulated, rectangular balanced, symmetrical biphasic pulsed current, rectangular balanced, asymmetrical biphasic pulsed current. So why do we really use NMES? It is for the restricted joint range of motion, whereby using NMES we can improve and increase the range of motion. We can control spasticity, edema, the pain relief and controlling the pain is done. We can minimize the effects of immobilization as well, basically to prevent the pressure sores, the circulatory compromise and atrophy. NMES is used for bone healing, for denervated muscles, for healing the wound. There are hazards of NMES. Hazards of alternating current can be tissue damage, respiratory arrest, ventricular fibrillation, and involuntary jerking can be seen. Hazards of high frequency are ventricular fibrillation and hemorrhagic effects in the heart. Hazards of direct current are basically tissue damage that can show up in the form of blisters with acidic reaction, tissue damage in the form of alkaline reaction causing burns. Tissue damage also has coagulation of protein in the microcirculation leading to ischemia. There can be burns, shock, irritation could occur. Cross-contamination is very common. Pain can increase. What are the parameters of NMES? We have waveform, frequency, modulation, safety switch, treatment duration, amplitude, pulse duration, phase duration, electrodes, and the output channel. We'll discuss parameters of NMES in detail. Before that, we have to understand about the instrumentation of NMES. So what all components are present in the NMES are, we have a power supply that supplies either AC, alternating current, or direct current with the constant voltage or constant current. We have a transformer. It is for the step up and step down to increase or reduce the strength of the AC. There is a rectifier that converts the AC to DC, alternate current to direct current. We have a filter that is used to allow only set frequency of current and block the frequency that is any different. We have a regulator. This regulates the voltage or the current. We have an oscillator used to modulate the current parameters such as pulse duration, waveforms, the frequency, amplitude, etc. We have an amplifier. So the final current or the voltage is amplified through this amplifier and sent via the electrodes known as cathode and anode to the patient. Now we have a few types of stimulators operated via battery or the line. So via battery are used for short duration of treatment. It has nickel, cadmium and or the alkaline battery that needs to be recharged or replaced. We have a line operated stimulator that is used for longer period of time of duration of treatment. Requires continuous power supply. It has sinusoidal alternate current. Types of stimulator based on controls are analog or digital. Analog has knobs and dials that controls and operates the oscillator, also known as hardware control. The digital one has digital push buttons and this is also known as software control. Understand the parameters of NMES. Starting off with waveform, we have monophasic and biphasic waveforms. Monophasic is where only one phase is present in each pulse. The current flows unidirectionally. That is positive and negative polarity. The biphasic waveform of pulse current is either symmetrical or asymmetrical in nature. The frequency is defined as the number of waveforms per second. It allows the user to set number of pulse per second to be delivered from each channel. And there is low frequency stimulator having 1 to 1000 pulse per minute per second. There is medium frequency stimulator having 1000 to 10,000 pulse per second. There is high frequency stimulator having 10,000 plus pulse per seconds. The duration of one complete biphasic waveform is the pulse duration. The duration of single phase of pulse current or the waveform is the phase duration. The treatment time present on many devices are seen via the treatment duration that can be adjustable up to 60 minutes long. And in some devices there is an audible signal that tells you about when the time gets over. There's a safety switch in upgraded and well-designed models nowadays, and this allows the stimulator to shut off in events of unexpected responses or reactions to a stimulator. Amplitude is the intensity or the rise of pulse from baseline. So this allows us to adjust the output voltage, and that depends on the stimulator. So it also helps to regulate the magnitude of current, where amplitude remains peak value of 100 to 200 milliampere or 500 millivolts. This is the normal amplitude waveform. This with the lowest reduced amplitude. This is with the increase in amplitude. So what is modulation? Now variety of modulation are important to enhance the effectiveness of NMES. This includes on time and off time. So a shorter on time than off time is preferred usually to avoid fatigue of muscles and nerves. The duty cycle is the ratio of on time by on and off time added into 100%. Ramping, there is ramp up and ramp down. So these are gradually increased and gradually reduced amplitudes. On and off time basically means that pulse can be periodically interrupted in cycles of rhythmical bursts. The output channel selection is the signal from the stimulator output amplifier via electrodes, the cathode and the anode. The output has variety of modes such as continuous mode, wherein both the channels provide uninterrupted stimulation for complete treatment session. There is interrupted mode, wherein both the channels from both the channels the output turns on and off at the same time. There is reciprocal mode, wherein there is alternate between the channels of on time and off time. So it will be on in the channel 1 and off in the channel 2, while off in channel 1 and on in channel 2. So this is how the reciprocal mode works. There is also a delayed mode. Now electrodes are the conductive material that acts as interface between the stimulator and the patient's tissue, the skin tissue. These electrodes are the means of electrons from stimulator output circuit that are converted into ionic current flow in the living tissues. So these electrodes require at least minimum 2 of them for completion to direct the current to the target tissues and to complete the circuit of electricity. Types of electrodes are seen as surface electrode, uses carbon metal, adhesive or sponge. Needles, percutaneous ones used in EMG, electroacupuncture. Surgically implanted electrodes are indwelling. Special purpose electrodes such as handheld ones for Bell's palsy, interferosis for rectal or vaginal stimulations. We have few configurations such as monopolar, bipolar, quadripolar. The single electrode placed on the target area and the second electrode is placed in distant area in case of monopolar configuration. Naming the electrodes are very easy. Cathode and anode is specified. So cathode acts as negative electrode that has greater concentration of electrons and the lowest threshold site for depolarization. The stimulation first is perceived here at the cathode. In anode, there is the low electrons and it is placed distant to the primary target area. It is also known as the reference electrode. It is to complete the circuit. Size of electrodes, the smaller the size, less is the contact area and greater is the electric current density. Material of electrodes are used such as rubber, metal, carbon, silver chloride. There is something that needs to be done to operate NMES, that is electrode coupling. We need to use a liquid gel medium between the electrode and the patient's skin surface. Why? To reduce the electrode subject impedance and to facilitate the electron-ion exchange effectively. There is metal electrode that requires soaked gauze or a cotton pad to be used before use, and carbon electrodes require electrolyte gel. Nowadays we see Caraya gum and polyacrylamide gel also being used. NMES is suggested to be used in stroke because of its various benefits. We have galvanic current and Faradic current. So the galvanic gives a stabbing or burning sensation to the patient. It's seen that if we increase the ramp up time, it helps in these recovery. The Faradic current can be used for re-education purpose, that gives around pin pricking sensations. So we start from day 0 and 1, wherein we use galvanic current first in the facet cases. Then we can progress to Faradic as the day progresses. When flexors are spastic, we can give stimulation to the opposite muscle group. Why? Because agonist contracts and relaxes the antagonist. We can give stimulation to spastic muscles. Why? Because the same muscle contracts and relaxes as seen by auto-inhibition method. In case of foot drop, galvanic is used first, and then once the contraction is achieved, we can switch to Faradic currents. The innervated muscles gets tetanic contraction on Faradic current and a brisk contraction on galvanic current. It is seen that the innervated muscles shows sluggish or worm-like sensations on galvanic, but then no response to the Faradic current. There is a degenerative phase wherein in early stage we can use Faradic currents and in late stages we can use galvanic currents. In the regenerative phase, we can use galvanic in early stage and Faradic in late stage. Now, to minimize pain, the electrode can be placed near to the motor point for the motor response. We have to be using pen electrode rather than using a pad electrode. So, we use pen electrode with salt water for increasing its conductivity and to avoid the burns. We use only the ECG gel rather than using a ultrasound gel. 100 to 30 ms milliseconds. The big electrode is shown to produce sensory stimulation, whereas a small electrode produces motor stimulation. In galvanic, the red electrode produces better stimulation, whereas in Faradic currents, the black electrode is shown to produce better stimulation. Now, prior to stimulation, we have to do certain things. That is, we can wet the area with a cotton dip in salt water. We can warm the skin to help increase the sweat gland activity via using hot pack for a little while. We can wash the area and then scrap the area. Now the physiological responses to the NMES is sensation and contraction. Chemical responses being commonly seen as redness. Certain cases burns can be seen, whereas Faradic has less chance of burns and galvanic has more chances of burns. And the least burn happens in sinusoidal currents, then into the Faradic and then the direct currents. There are multiple metabolic responses like swelling, edema. There are many benefits therapeutically seen with NMES.